Hello, my name is Stefan Krämer. I'm professor for environmental geochemistry at the University of Vienna. Today, I will talk about how metals are both a problem and a blessing for humans and the Earth environment. Specifically, I will discuss how metals are essential for all life, but also the cause of environmental pollution. How metals have been driving industrial development, but also play a key role in global carbon cycling. And finally, how metal mining had disastrous effects on the environment, but will also play a key role in the energy transition. But let me start with a bit of personal history. My great-grandfather was iron ore miner, and so was my grandfather, seen in this picture, that was taken in the mine in 1927. I'm sure that they were proud of their profession and were fully aware of their important role in providing key resources to industrial development and economic growth. And they knew what economic growth meant, as they personally experienced how difficult life could be in the poor area of Germany where they were originating. Fast forward to the early 1990s, when the aim to further economic growth was increasingly balanced by the awareness of its environmental costs. And in this spirit, I, the grandson of miners, was also working in a mine, but in my case, as a student of environmental geosciences, investigating widespread groundwater pollution caused by mining activities. Mining of metals for a better future and mining as an environmental liability. Evidently, me and my ancestors looked at the two sides of the same coin. But where do we stand today? Clearly, metals surround us. Whether we drive a car or a bicycle, whether we work in a factory or prepare a meal in our kitchen at home, we are very likely interacting with metals and metal-containing materials. Our jobs and our private lives, even the recording of this lecture, would be unthinkable without metals. On a very fundamental level, metals, including iron, are a prerequisite of life. If you ever took a pill containing vitamins and what they call minerals, these pills most likely contain metals such as iron, zinc, copper, manganese, molybdenum, and even chromium. All organisms, including you and me, need metals to live. And this has a multitude of important implications. Let me give you an example. The sunlit upper meters of the water column of large ocean areas, such as the South Pacific and the Arctic Ocean, contain extremely low concentrations of iron. So low, in fact, that phytoplankton, including phototrophic cyanobacteria and diatoms, have difficulties to grow, or in other words, the primary productivity is low in these ocean areas. And since these organisms hardly grow, they don't take out CO2 from the atmosphere by photosynthesis. And this limitation over a large part of the world's surface in turn influences global carbon cycling and the climate. Fertilizing the ocean with iron, much like fertilization of an agricultural field, only on much larger scale, has been demonstrated to lead to phytoplankton blooms, as you see in this picture, taken from space. Or to be more specific, you see a lot of clouds in gray, and peeking through the clouds, you see the ocean surface, with a heat map showing chlorophyll concentrations with warmer colors indicating higher chlorophyll concentrations. The semicircle in yellow and red shows high chlorophyll concentrations generated by this iron fertilization-induced phytoplankton bloom. The circular shape of this bloom is due to the course of the ship that dumped the iron into the ocean and the ocean currents, but you can see that the bloom stretches over a very large ocean area. Clearly, the effect of iron fertilization was dramatic. So dramatic, in fact, that it was proposed that ocean fertilization and the subsequent formation of large blooms by photosynthetic organisms could lead to an engineering strategy aimed at reducing CO2 from the atmosphere, but the efficiency of that idea is presently not clear. However, as much as some metals at low concentrations are needed for life, metal mining can have devastating consequences on the environment, as seen in the Rio Tinto in Spain in this picture. What you see here is a result of bringing oxygen into the subsurface, as mines tend to do, if only to allow the miners to breathe. This can lead to oxidation reactions involving the minerals in the mine. As a result, from that, mine waters turn into an acidic brew that we call acid mining drainage, containing all kinds of metals or metalloids in toxic concentrations, including, for example, arsenic. This is a rather widespread consequence of mining, but not the only one. Environmental pollution, ecosystem degradation, and effects on local populations, the list is quite long. So, should we stop mining? The problems associated with mining in the past and present are dire, but a key question that we may ask ourselves is if we need mining in the future. Take the energy transition as an example. I think I don't need to further elaborate that the use of fossil fuels and the resulting climate shifts are dramatically impacting all ecosystems of the Earth, and with it the human environment. It is imperative to stop using fossil fuels and arrive at different forms of energy generation and energy use. But what does that mean for metal mining? Take batteries. They are a key infrastructural element of climate change technology. They are needed for storage of solar energy or of wind power, and they are needed for electrical cars and maybe in the future even for container ships and air travel. It is likely that lithium-ion batteries will dominate the battery sector in the next decades, as they do now. Lithium is an alkaline metal that is increasingly mined in ecologically sensitive areas just for that purpose. But that is not all. For batteries, we also need metals like nickel and cobalt. For photovoltaic cells, we need aluminum, copper, indium, and silver. For wind energy, we need iron, copper, chromium, and lead. And I'm not even mentioning the wide range of other metals and non-metal elements that are needed in lower quantities. The World Bank has estimated the increases in demand for metals and other elements that are needed for energy transition technology to limit the global warming to 2 degrees Celsius. In the figure, you see the predicted demand increase in percent relative to the mining activity 2018. And it is rather mind-blowing, as we would have to increase mining activities for many metals up to about 500% relative to the mining in 2018. The consequences of that will be felt. Mining itself leads to greenhouse gas emissions, albeit in this case the reduction of greenhouse gases outweighs the cost. The degradation of land and its effects on the ecology of the mining areas, the impact on populations living in these areas, the effects on the availability and quality of groundwater, surface water, possible air pollution issues, all that needs to be taken into account. And also the question if there will be equal and fair access to the metals that are mined, rather than that leading to new monopolies. What can we do? When I started my career as student of environmental sciences working on the environmental consequences of mining, I would never have dreamt that one day I would have to face a situation where the solution to some of our most pressing environmental problems appear to require more mining. My grandfather and great-grandfather would not have been surprised at all. I personally believe that it is not a time for polarized views on mining, but we need to do a better job than we did in the past. I see it as an imperative that we as scientists and engineers focus on strategies to develop energy transition technologies that have a lower material demand and allow efficient recycling of metals, and that we develop environmentally and socially better ways of mining for the metals that are needed beyond that. And therefore, if you are interested in metals and metal mining, be that from a governance or social perspective, from an environmental science or engineering perspective, I think it would be very worthwhile to pursue this interest. Thank you.